Thank you for the invitation and the opportunity to talk to you all. As ground rules, if you don't understand what I said, please interrupt me and we can clarify that. If you don't understand why I said what I said, please hold that to the end and we can discuss all of that. So I welcome questions. I welcome. I think you're all wrong. That's fine, but we'll do that at the end. Okay, here's where we're going. First, I want to talk about some foundations of Bayesian ideas, just to clarify where we're coming from. And I particularly am interested in showing you the impossibility theorem having to do with interpersonal Bayesian matters. And I also am eager to talk about solipsism, which maybe you haven't heard of before, but hey. I will give an example concerning an environmental problem that I worked on and talk a bit about communication. So that's where we're going. Okay, so first, about risk and uncertainty. It is probably unfortunate historically that these two words have come to mean what they have come to mean. Keynes and Knight are really the two people who emphasize this the most. And roughly the idea is that risk were matters on which the probabilities were agreed to by everybody. Think of flipping a coin, okay? That kind of thing. The difficulty, of course, in the real world is that those kinds of instances are rare. And all the rest gets wrapped up in uncertainty, which is we don't know, and there isn't a particularly compelling reason to think one particular thing as opposed to another about it. Well, I lost my page, didn't I? Wrong way. Okay. Knight was an economist, and I think more a theoretical economist. He didn't have to deal with the real world. Keynes was a different matter entirely. Keynes, of course, is a famous economist, but he started in logic, and he was hoping that somehow uncertainty would be a suburb of logic intellectually. It didn't work out that way, but that's what he was hoping. A lot of people were hoping things like that. The difficulty is that really there's a continuum of, shall we say, agreement of probabilities about uncertain quantities. There can be wild disagreement on one hand, there can be near agreement among most people on the other hand. And these names have become synonymous with the two poles of that continuum, but really they're all about uncertainty. Some of them there's more or less consensus about. Keynes, in addition to being having come from logic, but being a very fine economist, was also a very practical man. He was, for example, managing money for his college. And as such, he had to deal with the real world and with real uncertainties. Here's what he had to say. The sense in which I am using the term uncertain is that in which The prospect of a nuclear war is a European war is uncertain. The price of copper or the rate of interest 20 years hence, or the obsolescence of a new invention, or the position of private wealth owners in the social system in 1970. About these matters, there is no scientific basis on which to form any calculable probability whatever. We simply do not know. Nevertheless, the necessity for action and for decision compels us as practical men, to do our best to overlook this awkward fact and to behave exactly as we should if we had behind us a good Benthamite calculation of a series of prospective advantages and disadvantages, each multiplied by its appropriate probability waiting to be summed. In other words, when it really came down to making decisions, Keynes is a Bayesian all the way, okay? And the rest of it was wishing that there were consensus, wishing that uncertainty were risk, but it isn't. So let me just leave that where it is. So personal probability and utility. They may be matters of agreement, they may not be. And so we have to deal with the general case. The case for subjective probability is essentially that you are announcing bets that you would make. And the only rule is that you don't want to make bets such that somebody else could make you a sure loser. In other words, heads you lose, tails you lose. You want to bet. So it's a very elementary consideration. It avoids an obvious error. And that's all it's doing. Okay? There is this forlorn wish for objectivity. People wish that probabilities were objective, but they aren't. In fact, we wish that we knew with certainty all sorts of things about the world. We're not given to know certainty. And so the truth is that it's all uncertain. And we have to deal with that. And it doesn't do us any good to pretend that matters in the real world are certain when in truth they're not. Oh, I lost my page again. Okay, so the authors that I'm looking to are Ramsey, De Finetti, Savage, and later Lindley, also de Groot. So it's that sense of expected utility that I'll be talking about. And there's a theorem in that theory that says that maximizing expected utility leads to optimal decisions. I'm assuming that that's basically material that you all have at least heard rumors about before. Now, question, in what sense are these optimal decisions? Are they necessarily ethical? No. Ethics had nothing to do with it. It's just what is your utility function? How what are you trying to maximize? They may be things that people would regard as good things to maximize. They may be regarded as things that would be evil to maximize. All that's included because those considerations did not go into necessarily into the elicitation of either probabilities or utilities. Okay, so these are not necessarily wise decisions. The most ridiculous beliefs can be expressed in these terms. somebody may put probability 1 on the hypothesis that the moon is made of green cheese. And the rocks that have come back from the moon, that was either a conspiracy or it's really hardened green cheese, or who knows what they would come up with, okay? But the point is that you can be coherent and believe truly remarkably silly things. There's nothing in this theory so far that says anything about any of that, okay? So it is a very foundational, but a very low bar on what's allowed to be expressed in this theory. Optimal only in its limited sense of being something we can calculate, and that if those are your probabilities and that were your utility, this is what you get. Okay. Now, an impossibility theorem. What about two Bayesians? They each have their own probabilities and they have their own utilities. Okay. And their probabilities are not the same. That is, there are events on which they differ. And their utilities also differ in the sense that there isn't a linear relationship between them. Okay. So this is the general case. And they want to find a compromise. Now, what's meant by a compromise here? You could imagine many different kinds of functionals being proposed as compromises. The sense of compromise that I'm suggesting is only the following. If both parties find that option X is preferred to option Y, then their compromise has to prefer X to Y. Okay, so it's sort of a first order good sense of what a compromise might look like. Okay, the fact is that under those conditions, they're looking for a Bayesian compromise. That is, a probability and a utility that will express them jointly. There aren't any. The only thing they can do is do it all one person's way or all the other person's way. Those are the only two cases where they can have this kind of compromise. So that means that in a very deep sense, that it's Bayesian statistics, Bayesian theory is personal and doesn't extend to groups in a graceful way. Sorry about that. So all these ideas about we'll get experts together and they should agree on things, they're up against this in one form or another. So that's just the mathematics of the matter. We'll have to deal with that. So are there questions about what this says? Have I lost everybody? Okay, I will go on. So Bayesian decision theory doesn't extend gracefully. So what are the options? Do groups have to face sure loss? That is, make bets that they're sure to lose. should they understand that they will be making decisions that nobody likes? That is, that everybody in the group would prefer a particular other option to the one that's on the floor now. Or must they revert to autocratic rule? That is, do it one person's way, and that's the way it's going to be. Well, I will refrain from the politics of that. So these are some of the questions that I think this theorem raises for interpersonal Bayesian ideas.
Can I ask you about
Sorry?
Is there a way to twist it? Like
I can't hear you. Sorry.
Is it a way to twist it in a positive manner, like that if there's a group that are in agreement, then they have to be linearly dependent in their.
I suppose. I suppose that's true. I find we should hold this for the discussion. It's fun, but let's do it at the end. Okay, so now I want to talk about solipsism. You probably haven't heard of solipsism. Solipsism comes from two Latin words: solo, which means alone, and of course in English we have the same word meaning the same thing, and ipse, which is self. And so solipsism is a view of what we can know, which is only what's in our heads. That's what we experience. Okay. You've heard, I'm sure, of cogito ergo sum. That's Descartes, and it means I think, therefore I am. In other words, I know my thoughts. And most distinctly, it is not cogito ergo sumus, we think, and therefore we are. What solipsism amounts to is that a solipsist would know only their own existence, and the rest of everybody is sort of out there, but it's not clear that they exist in the same sense. Now, by giving this talk, I've already revealed to you that that I am offering thoughts, and that I'm expecting that means something to you, and that and I'm also saying that I care about what you say, what you think about these things. I am not a solipsist. There's a commentary about solipsism which says, well, no great philosopher has espoused this. Well, okay, but hang on a minute. Suppose somebody was a great philosopher and really believed this. There would be no reason for them to write or to speak, because there's nobody out there to a solipsist. It's all in their own head. And so there may be great philosophers who sit on in their mountainside or whatever, and just don't talk to anybody, because there's no point in doing that to them. So there's a missing data problem here. There's a censoring mechanism that prevents us from experiencing solipsis. Okay, well, but there's a point to this, namely, here's a Bayesian who's done their Bayesian work. They say, here's my prior, here's my likelihood, here's my data, and so here's my posterior distribution. Best regards, right? Now, what's going on there? They have given their opinion, their utility, their likelihood, and their conclusion. So what? what does that mean to anybody else? If they stop there, what they're doing is essentially solipsism. That is, they're cutting themselves off from all the rest of us. So my suggestion is that this is a trap for subjective Bayesians. There is a way out of this trap. Namely, you have to explain why you made the choices you made. What considerations led to this prior? What considerations led to this likelihood function, this utility? Explain why. That's the real substance of the matter, rather than simply the Bayesian calculations. In other words, it's incumbent on us as non-solipsists to explain ourselves. That's not something that is part of the Bayesian paradigm itself. It just says, get me the probabilities. But to communicate to other people, one has to explain why. Okay? And so I believe that solipsism is a danger for subjective probabilists in that it suggests that all that's necessary is for you to state your opinion and you've done your job. Well, you haven't done your job. You've essentially, if you like, written the abstract of a paper, but the substance of the paper is why. What considerations lead to this? What other studies? What analogies? However you're thinking about the problem, why did you make these choices? Okay, so that's what I have to say about solipsism. Now, an example, a real example. This has to do with the hypothesis that perhaps tropical cyclones, that is hurricanes, have increased in the North Atlantic since the Industrial Revolution. Okay, it's certainly a natural thing to suppose that maybe that's true. And there is a database called HERDAT, which is shepherded by physicists, and they require 2 independent measurements of the wind speeds of a storm for it to be included in HERDAT. And how much wind they record determines what level of hurricane it is regarded as being. Okay, so and HERDAT shows, sure enough, that there's been an increase in hurricanes. But wait, at the beginning of the period, the only way that hurricanes were observed were either from landfalls or from ship observations. At the end of the period, we have satellites looking at everything, including hurricanes that last for a very short period of time. That is, that get up to the speeds required for only a short period of time. In between, the kinds of things that were important, the development of radio communication between ships was an important matter. The opening of the Panama Canal was an important matter because there were many more ships going through the Caribbean after the Panama Canal opened. After World War II, airplanes were used to to observe hurricanes. And increasingly, as technology has improved, satellites have improved a great deal in terms of what they can actually record. So there's been a steady improvement in our ability to detect hurricanes. So it should be no surprise that HERDAT shows an increase, because they're just recording the ones that are well documented. Okay, so to do a model of this, one needs a model of suppose you did know about all of the hurricanes in this period. What kind of slopes do you get? And you have to take into account interdecadal sine curves that are going on in this, and so on. So it gets a bit hairy, but not too hairy. But the other thing is you need a model of detection. And that's a much more difficult thing, because it has to do with, for example, in the early period, there was a thought that at least some ship captains could tell by timing the slapping of waves against the hull of the ship whether there was a storm brewing or not, and would then take actions to avoid the storm. Okay, well, if that's true, then even in the early period, one is missing hurricanes that ships otherwise would have observed, and so on. So it gets very delicate. One way you might imagine doing it is saying, well, let's suppose that now we're seeing all the hurricanes, and we know their track and we know their intensity. Well, okay, let's take detection capability as of 1900. What's your probability that this hurricane would have been detected? With 1910 technology, what's your probability? And so on. Well, you could try that. Of course, these are going to be correlated. That is, if you think well of 1900 capability, then 1910 can't be worse. And so there's going to be a correlation between your view of 1900 and 1910 for this particular hurricane, let alone all of them. So it's a hairy problem, and that was the problem that we were trying to address. So we had a model for detection. And what were our results? Well, oops, that's the wrong way. The fact is that there's one parameter in our detection model where if you change the prior a bit, you can get increasing, constant, or decreasing hurricanes over the period in question. So what are we going to do about that? Okay, well, here are some choices. One could choose one particular prior and just not mention anything about the others. That's solipsistic because you're not communicating what you know, and you're just picking a value and saying, well, suppose it's 3.2. Why 3.2? We don't go into that. We just say, suppose it's 3.2. Then you get this particular result. And a lot of people could take that result and go argue about climate change as a result of this paper, which shows, they claim, some particular result about about hurricanes. You could choose one that agrees with your particular politics, that it's increasing or that it's decreasing. That's not only solipsistic, that's unethical, because you are actively fooling people about the results. What we actually did was we reported all three, and our conclusion from this study was, we don't know, and the truth is, you don't know either, and nobody's ever going to know how many hurricanes there were in 1890 in the North Atlantic. So if we talk about climate change, and we must, we'll just have to leave hurricanes in the North Atlantic out of it, because there's too much uncertainty about that. We just don't know, and we're not going to know. There's really no way to go back and rerun that. So my point is that all three of these are consistent with Bayesian decision theory on its face. That is, all three of them have a prior, a likelihood, a posterior. But that's not the scientific story at all. The scientific story is that there is substantial uncertainty there, and we just have to live with that. Okay, so that's why I feel it's so important that we avoid solipsism. We avoid the justification for what we're doing as being, well, that's what I think. The proper answer to, well, that's just what I think, is, okay, that's what you think. There's not any reason for me to think it. If you want me to think something like that, you have to explain to me why you think so. And if I find those arguments persuasive, then I might move in your direction. But simply because you think it is a fact about the world or about your mind, but is not a fact that impacts my thinking about it until I understand your thinking process. Okay.
Is the one that you picked, is that hard to explain? Is that really
what?
Is the one that the prior, the decision you have to make?
Yeah.
Is that parameter hard to explain what it is? Or?
Not so hard, but it's embedded in the model. Mm-hmm. And so what it means is only in the context of that model. And in that sense, a prior involves all the parameters jointly, and yeah, so it's not something that's going to leap out. So about communication, I want to take COVID-19 as we all have it on our minds, so we may as well talk about it. My suggestion is that what's appropriate is not just communication, but who are you communicating to? And you have to take your audience into account in what's announced. So my suggestion is, so say one level of this is a government official who is going to say, this is what we want people to do. We want you to wear masks. We know that this is a communicable disease, so a sick person can give it to other people who are well at the moment. So our advice is to wear a mask and to avoid crowds and all the other things that they were asking people to do to limit the extent of it. That's on one level, but there's a second level, namely, what about the scientifically minded? Well, that should be announced not by a politician, but by a chief scientist. And it should go into, here's what we know currently, here's what we don't know currently, here are the tentative conclusions that we've drawn from what we know, and here's what we're doing to find out more. And stay tuned. And will be updated frequently, but only goes to the Secretary of Health when there's new advice. For example, finding out that COVID is not transmissible by touch, but by breathing air particles, and so that's important information that changed. I remember in the beginning, everybody was washing their hands, and that was supposed to help with COVID. Well, I'm sure washing your hands is a fine thing to do, but it didn't have much to do with COVID. What did have to do with COVID was the air that you breathe and whether that had virus particles in it. So, so the idea of this is that you are taking into account, in this crude sort of way, the level of sophistication of your audience. You're making both available to everybody, but to the public, you're just telling them, here's what we want you to do. And to the scientifically minded, you're explaining in much more detail why those recommendations are made now, and the kinds of things that may change those recommendations at a later date. And that could be updated all the time. So in the end, the view that I want to offer about Bayesian statistics is that it should be respectful of people with different opinions and desires, and has to be honest about what's known and what cannot be known from the data, what the data can support and can't, and that at least if an investigator has a horse in the race, that they should reveal that, so that that can be taken into account also by others in deciding how they want to view the issues at hand. Okay, so this is the general view that that I want to offer. So what I'm saying then is that when I think about interpersonal Bayesian statistics, it's not enough to have a prior and a likelihood and a posterior. You have to think about, who are you talking to? How are you going to persuade them if that's your goal? How are you going to at least reveal to them where you're coming from? What are the considerations that lead you to particular things? I've told you, for example, in the case of hurricanes, why I would recommend that people not take HERDAT as if it were complete data on hurricanes, because there's this obvious problem of detection. And you simply have to take that into account, I think, in order to understand the data. Okay, so say a hypothetical Bayesian model that just took HERDAT and extrapolated or something, I would find unsatisfactory for that reason. But I have explained to you why I think it's unsatisfactory, and I hope that I've at least persuaded you that there's some rationale for that. So that's what I plan to say. Come at me.
I will try to moderate the questions. Yes.
Good luck.
And please, before you ask a question, it's nice if you say your name so we know who you are. And yes, is there anyone that would like to ask a question to Jay? Yes. You have to speak up.
Okay, Sarah Duggett, King's College London. I was really interested in the two-tiered approach for the COVID communication.
I'm sorry, I can't.
Maybe
hear
you just have to come up here.
Sarah Duggett, King's College London. I was really interested in the two-tiered COVID communication system that you had with the what's for the public and what's for the sort of scientifically minded, I think you described it as. I was interested in how you define sort of that scientifically minded group, who you would put in that, who had access to that sort of ongoing document. Would it be just GPs and epidemiologists and the government, or would it be just the government, or would it be risk communicators as well?
Oh, my thought is that would be open to everybody, but it would be written for the scientifically minded. Okay, so it would be there for anybody who wanted it, but the first intended audience would be people who are willing to sit still for this paper, that study, why we don't take that study too seriously, and so on and so on.
I was just interested in also because we know that like the ongoing uncertainty often is open to misinformation.
The
ongoing uncertainty sort of documents often open to misinformation and disinformation. Do you know how would you
Yes.
address that, or just like
how would I address that? Well, of course, the difficulty there is that one person's information is another person's disinformation. And so we're back in the same soup. I'm not sure that those names are helpful to describe situations in which people have radically different views.
Thank you.
Okay.
Please.
Yes, please.
Danielle from Amsterdam, UMC Department of Public Health.
Yes.
So I think follow up on this question from the previous speaker, and I go to what happens during the pandemic. One of the problems is that this in Netherlands was that the government only communicated you have to do this, that, and that, and then they changed their mind. Of course, new insights, but that didn't tell that. And then, oh no, you do have to wear masks, or asymptomatic people are indeed contagious. So that's the problem with the two-tier approach, that people get really confused if you tell them only what to do and don't explain what you want to do. It's up to the scientists, I think, the experts, to better explain why they changed their mind, and they didn't. So I think this is not a good way to do this. And maybe people, citizens, also want to know why this, why do you change your mind? So you need to explain it to them.
Well, I'm all for making it public. What I'm suggesting is that there are some people who just want to know, what do you want me to do? I hear you that there's a problem. Give me a paragraph of what you want me to do. There are other people who want to go much more deeply into why do you want me to do those things? Fine, that should be available to them too.
So it's one tier communication. It's only one way of communicating. You have to tell them what to do, why you have to do that, when you have to do that. So it's one communication.
Well, it can be, or if you like, it can be the executive summary is what you want me to do. The substance of the thing is, why do you want me to do those things? And what's the science behind it?
Yeah.
And where are we really uncertain? But this is our best guess now, and this is why. Maybe because of what we learned from previous viruses and how they were transmitted and what methods worked for them.
Total science system that most people want to know.
Well, with respect to some things they do, with respect to some things, it depends. And the next one may be different in who knows what ways. But what I'm really suggesting is that we not have a cookie cutter view that the people want one kind of communication. That doesn't have to be the case. It could be that some people want one kind of communication and some others want a much more detailed communication, in which case both should be available.
Layered communication, yeah.
Yes,
Yeah, well, yeah.
yes, exactly.
But in the first layer, you also have to explain why, I would say.
Well,
So basically,
if that is, there are people with short attention spans for this sort of thing, and people with long attention spans. And I think an appropriate communication has to realize that people differ and address people as best it can where they are.
Hi, I'm Ellen Peters. I'm from the University of Oregon. I just want to follow up a little bit on what Danielle was saying.
Sure.
Part of what happens if you provide people with just you must do this. One, it takes away their freedom of. They can feel as if it takes away their freedom of choice, and then they react and be less likely to do it. But then I think the bigger problem, which I think Danielle is probably alluding to, is the idea that in an ongoing situation like this last pandemic. If you tell people do this, and then the science changes as it inevitably did, and they don't have forewarning that it might change, and then it might change again, they do react and they lose trust, and then the communications after that are less effective because suddenly the person who is the trusted messenger becomes less trusted over time. And so I really like your more general point of the layered communication. What I would add to that general notion of layered communication is we need more testing of risk communication so that we can figure out how to tailor communications to different folks and how that changes over time, because it does.
Yeah, there's a dynamic problem there.
Yes.
And the problem with the dynamic issue is that you don't know how many times in the future you're going to want to change. No doubt people will make a guess on that and be wrong. But I think that making the detailed information available is, of course, the right thing to do. But people have limited attention spans for everything. And we have to take that into account also. In other words, it's a matter of addressing the audience where they are and being sympathetic to that. I would not suggest to the government that they announce you must do this, you must do that, but rather we want you to do these things because our best understanding of the science of this matter now is that those are the things that will help the most. And not put it as a requirement, although if you want to get on an airplane, at one point you had to wear a mask. Okay, you don't have, you can walk if you want to. So it's not taking away anybody's freedom, but sure, there are going to be people whose danders will be gotten up by too heavy-handed a government hand in how it's announced. And I'm aware of that too.
But people also have their own prior probabilities, and if they don't match the behavior they are required to do so, then they don't believe you also. So you must know the prior probabilities of people.
Sure.
That's also a problem. And that's where one of the things when things went wrong also.
One of the things.
It went wrong in communication during the COVID pandemic. Don't take it into account the reason from the prior probabilities of the country.
Yeah.
In a general way, not in mathematics.
So I think that this all fits in with what I was saying, in that one has to be respectful of other people's situation and understanding and explain it, rather than simply declare. And it's the same mistake when one does an analysis and just justifies it by saying, well, that's my opinion. Well, so what?
So you do have to give arguments for
Yeah.
So that's
All right, we have,
There's another one.
please introduce yourself. Yeah.
Hi, Kadane. I'm a researcher at the Stockholm Environment Institute, SCI. I have a question about time. Is that anywhere in your equation? Does that affect your decision tree or how you think about, what you presented today?
Time.
What aspect of time do you have in mind?
Well, that's a good question. I guess time could be related to the sense of urgency, but it could also be related to what you were alluding to, people's circumstances and the scope and space that they have to take in new messages, how long an event goes on. I'm assuming timing, I'm not a communicator, I'm not working with health, but timing when we work with communicating research is absolutely important. So how can we factor that into patient decision?
Well, I guess it also it depends on the circumstances, how time factors into things, and how quickly whatever is going on, and one has to take that into account, of course.
Yes, I have a question.
Please.
You were talking about the when one is applying Bayesian statistics, maybe as we see here, then it is only personal. It's the results depends on the judgments made by one person.
Yes.
And then you said that one cannot combine conclusions from several people. Or if you have groups, for example, of experts that are going to work on something and reach a conclusion, then you said that it's not possible to combine their opinions. And I find that a bit distressful because I see a room of experts working together, scrutinizing the evidence, and then they want to reach a conclusion, and maybe they are using this framework to reason. Is it possible to combine judgments by several people?
Oh, it is certainly possible to combine judgments. You can, for example, take any convex combination of their probability distributions, and you've got a new probability distribution, which is what it is.
Mm-hmm.
And you can try to sell that as their consensus, if you like.
Mm-hmm.
Maybe other people will buy it, maybe they won't. I would prefer encouraging them to discuss their reasons rather than simply nail together their probabilities in some mechanical way. Does that address your question?
Yes,
Okay.
but there are still practices where we are combining things, and then we maybe we are straying away from the theory then, and we are actually working under other conditions.
Well, there are all sorts of things that go on in the world. Some more important, some more unfortunate than others, depending on the circumstances.
Okay. Any other question to Jay? Right. You can also talk to him in the break that we will have now. So I suggest that we have 10 minutes break, and then we join here again, and we can give him a floor.
Ulrika, vad har du tänkt på sista session? Vad har du tänkt? Jag ska leda en diskussion. När kan det ske?